Hello, welcome. Today I will prove the famous limit result, trigonometric limit theta approaches 0, sine theta over theta equal to 1. Okay, as a bonus, um, we will prove this also. Limit theta approaches 0, 1 minus cosine theta over theta equal to 0. Okay, this result is actually a consequence of the first result. Okay, so before proceeding, I need a diagram. Yeah, this is a unit circle with a radius. Yeah, radius. Once again, line segments again. Why this? Can word lines. Once again. Yeah, I will use my pencil again. So this is the radius r is equal to 1. Okay, and a tangent line okay. Now this is our angle theta, and this is a unit circle, and we know that at this point the coordinates of this point is the x coordinate is the cosine of theta, the y coordinate is the sine of the theta, and what is this opposite side is the tangent of theta. This one is the tangent of theta. Okay, look at this the triangle, and also we can draw a sector here. Okay, consider the area of the sorry, not the sector, the a triangle inside the sector. Okay, so you can see three areas. One is the area of the triangle inside, and the area of the sector outside, area of the sector, and the area of the triangle, the big triangle. Okay, and we know that the area of this triangle that's equal to, yeah, this is also r is equal to 1. If r is equal to 1, the area of that triangle is half AB sine C. Sorry, yeah, half AB sine C. So half times A and B are 1. 1 times 1 is 1, and sine C is the angle, so that is sine of theta. Is less than the area of the sector. Okay, what is the sector of area? R squared theta over 2, or 1 half r squared theta. So 1 half r squared is 1 squared, so that's 1 times theta is theta. This is the area of the sector. Is less than the area of the big triangle. Big triangle, the height is the tangent theta, base is the radius, that is equal to 1. So area of the big triangle is half times the base times the height, so that's equal to half times, and base is 1 and the height is tangent theta. Okay, so this is the result. Inequality. Yeah, not the result. Yeah, we need that result again, so we will utilize this inequality. Okay, let me write this as more compact form. Sine theta over 2. Yeah, let's cancel the 2, no problem. Okay, we can cancel the 2. Sine theta is less than theta is less than tangent theta, whatever theta may be. Okay, inside this first quadrant. Okay, we need to let the theta approaches 0. Okay, so before that, let's change this inequality. Okay, let's manipulate this inequality. Okay, we can divide the sine theta with a sine theta. Okay, here sine theta, theta over sine theta, tangent theta over sine theta, and let's remind you, sine theta over cosine theta equal to tangent theta, So tangent theta over sine theta is 1 over cosine theta. Okay, so this is 1 is less than theta over sine theta. Let me write in proper form. Yes, theta over sine theta, theta over sine theta is less than tan theta over sine theta is 1 over cosine theta. Okay, so let's take the reciprocal of these quantities, then the inequality will be reversed. Okay, so the reciprocal of the 1 is 1 greater than sine theta over sine theta over theta greater than cosine theta. Okay, let's reverse again. So cosine theta is less than sine theta is less than theta is less than cosine theta. Okay, sorry, 1. Yeah, it's 1, sorry. Okay, if this inequality holds for theta, if you use inequality symbol, sorry, equality symbol also here. Okay, because we need to let the theta approach 0. Okay, yeah, now we can apply the limit here. Okay, so this is the limit we need. Limit theta approaches 0. What happened to this inequality? Yeah, let's use this inequality with the equal symbol. Okay, cosine theta is less than or equal to sine theta over theta less than or equal to 1. Okay, we know that as theta approaches 0, theta approaches 0, this is 0, cosine theta approaches 1 less than or equal to the unknown limit sine theta over theta less than or equal to 1. So we excused theta approaches 0. We excused the sine theta over theta between 1 and 1. This implies limit sine theta over theta equal to 1, because we excused the limit sine theta over theta between 1 and 1. Okay, we excused the limit sine theta over theta between 1 and 1, so the result is 1. So sine theta over theta as theta approaches 0 is equal to 1. Okay, now let's prove the next result. The theta approaches 0, 1 minus cosine theta over theta using this result. Okay, now the second one, limit theta approaches 0, 1 minus cosine theta over theta equal to limit theta approaches 0, 1 minus cosine theta over theta. Let's use some trigonometric identity. 1 plus cosine theta over 1 plus cosine theta. We can multiply limits with the equal quantities, and now this is equal to limit theta approaches 0, 1 minus cosine theta times 1 plus cosine theta equal to 1 minus cosine squared theta over theta times 1 plus cosine theta. That's equal to limit theta approaches 0, sine squared theta over theta times 1 plus cosine theta, because 1 minus cosine squared theta is sine squared theta, a famous Pythagorean identity. That's equal to limit theta approaches 0. We can split limits sine squared theta as sine theta times sine theta, and we can split the denominator as theta times 1 plus cosine theta. So that's equal to 1 times, this limit is 1. We proved that this limit is 1. We can apply the theta is equal to 0 here. Okay, theta approaches 0, sine theta over theta is 1, and sine theta is sine 0 now, 1 plus cosine 0, so that's equal to 1 times 0 over 2, that's equal to 0. So the second limit is, limit theta approaches 0, 1 minus cosine theta over theta equal to 0. This is the second result as a balance. We will use this, the application of this limit, the limit result is in differential calculus to derive the differentiation formula for sin x and cosine x, that we will do in the next video. Thank you.